Alright, so for Fisher projections, very similar to what we did before, we can figure out R and S. So we're going to do a practice problem here, but you're going to again need your model kit. So with your model kit, one thing you want to recognize is that the way that we view these is that we view these as if they were wedges, so they're pointing towards you and dashes. So I'm going to make one and show it to you, and then we're going to figure out whether it's RS. But before we do that, let's look at the priorities. So attached to this carbon here that I'm going to make a little dot, our first priority is going to be oxygen, which is number 1. Our last priority is hydrogen, which is number 4. Now let's figure out what the other two are. So we have carbon and carbon. So they're both the same thing. So now we go and look at what's next door. So this carbon we pretend is attached to 2 oxygens. This carbon we say is attached to 1 oxygen, 1 carbon. So this one is going to be our number 2 priority and our number 3 priority. So we're going to build this. I'm going to show you what that will look like, and then we'll try a problem. I'll give you a problem to try. Alright, so we have our enantiomers that are non-superimposable, because I can't put them, no matter what I do, I can't put them on top of each other, so non-superimposable mirror images. So chiral centers actually have, for carbons, 4 different groups around each carbon, and so to make a molecule chiral, there has to be no plane of symmetry. And so we see that with these enantiomers. So for the purpose of our Newman projection, what we want to do is align our molecule so that it fits this Newman projection. So I'm going to take one of my enantiomers and I'm going to align it. So before we do that, like we just did a little while ago, I'm going to draw on my, that was our first priority, 4th priority, 2nd priority, 3rd priority. So remember, I always do red, green, blue, white. So we're going to align it, and so we want our highest priority red to be pointing towards you, and our lowest priority white also towards you, but pointing, so kind of like this. So I'm looking at it like this with the oxygen, the OH group on the right hand side towards me. So I'm literally looking flat. So if I rotate this, you can see it's flat in front of me. But my my 3rd priority, which is going to be my blue, is downwards, so I need to swap my atoms. So green is at the top, so back at the top. So if you want to see, if I held it this way, you can see those are pointing downwards, these are towards you. So I'm not looking at it kind of in the bouquet style that we typically do. And then when I rotate it and I go red, green, blue, red, green, blue. So I go in the R direction, red, green, blue, clockwise, okay? Next one, so we had our Newman projection for the amino acid. The previous ones were sugars. This is now an amino acid, and our priority was 1, 2, 3, 4. So I'm going to do the same thing. I'm going to take my model, and I'm going to put my red pointing on the right hand side of me, up, the white to the left and up, right? And again, I'm building it according to my model, so I'm kind of just aligning it with my model. My green back and to the top side, and then the blue to the bottom side. So remember, again, I always go red number 1, green number 2, blue number 3, and white. So if I do this again, I go red, green, blue, that's clockwise, so this is also R. So try this with the model that you were assigned.